Hey Math 1, section 2.5 is coming at you. These problems, these equations that I'm asking you to solve look very similar to the ones that you saw in sections really 2.3 and 2.4. But you'll see that there's one main difference here in a little bit. And that's why I've labeled it the special cases. Let's just dig in and see what we find. So looks pretty standard. We have parentheses on the left-hand side, on the right-hand side too. Make sure that you're still retaining this idea of whatever is on the outside of parentheses, directly on the outside, there's no operation listed between them, that you're multiplying. So you get 3 times 2x is 6x. 3 times negative 4 is minus 12. The plus 7 comes down. Nothing out of the ordinary so far. Equals. Make sure you do not do 2 plus 2 to start, because multiplication comes before addition in the order of operations. So it's just this 2 that gets distributed through the 5. That'll be 10. And this 2 gets distributed to the 3x plus 6x. And then don't forget this 2 right here that's going to drop into place. All right, that's our first move. I use the distributive property to get rid of parentheses. Second one is I want to simplify the right-hand side independently of the left-hand side. So it's like, hey, I'm going to do 2 plus 10 before I start moving numbers to the left and right of the equation. So I'm going to say that this is 12 plus 6x, and then negative 12 plus 7 is going to be a minus 5. The 6x just drops down. So now it looks like one of the basic equations from section 2.3 where all you had were variables on the left and right hand side and you had to know what to do when that happened. So I'm a big fan of moving the variable term to the left hand side of the equation. So I'm going to take this positive 6x, subtract the 6x from the right, and then subtract it also from the left. And you can do that because of the subtraction property of equality. So 6x minus 6x is just 0, but it's also 6x minus 6x over here. So that zeroes out as well. So you have 0 minus 5 equals 12 plus 0. Now this is kind of confusing. There's no more x to solve for. We're just left with negative 5 equals 12. Which is clearly not a true statement if you just look at it based on its logic. It'd be like somebody says, I have $12. You owe $5. That's an equal amount. That's not an equal amount. So we're kind of left with a false statement here. So this is not true. It's a false number statement. What are we supposed to do with this? This means there's no x value that makes this equation a true statement. There's no x's. There's no solution. And that's what we would say if you drop the x's and we're left with just kind of a gibberish false statement. There is no solution. Solve for x. There is no x to make this happen. So there's our first special case. There's no solution to this equation when the x's drop out and you're left with a false statement. I'd actually write that somewhere on the notes, okay? There is no solution if two things happen. A, the x terms completely drop out. They zero out. Or become zeros. And you are left with a false number statement. All right, so now that we've got these special cases, we're going to have to start, we have to be on the ball with our thinking. We can't just be like, do a bunch of algebra. You have to now make decisions sometimes when these special cases come up. All right, we've been warned. Let's try number 2. Yeah, I'm going to need some more space. Here we go. We're going to move it on over. Okay, and here's number 2. So starting with the 3 minus grouping symbols here, make sure that you distribute the negative to the 4 to create a negative 4, and distribute the negative to the negative 3x. So a negative times a negative is a positive 3x. The 3 was not included in this process because it's 3 minus, not 3 times. So you're just going to have the 3 from there drop down. And then this all equals 3x minus 1. All right, after the distributive property, we're going to just simplify the left-hand side. So I can do 3 minus 4, that's negative 1. The right-hand side's already simplified, so I'm just going to rewrite it. And then, of course, we're going to try to, make it look like a simpler problem by getting the x's together. So I'm going to take this positive 3x, subtract 3x from both sides. So zeros it out on the left and zeros it out on the right. So I get 0 minus 1 on the right, and I get minus 1 plus 0 on the left. So it kind of looks similar to what we had over here. Yeah, the variables dropped out completely, but we were left with a false statement. Negative 5 does not equal 12, and that's why it's false, and that's why we put no solution there. If you look at number 2, yeah, the x's dropped out, but negative 1 does equal negative 1. That's a true statement. This is a true number statement. Statement. So what does that mean for us? Well, when you think about this equation, let's go back up to this step right here. Can you guys see that? Now you can. If I were to just investigate this a little more closely, I could rewrite this as 3x minus 1 because the commutative property says I can flip them around that way, just as long as I keep the 3x positive and the 1 negative. So this is the left-hand side using the commutative property. The right-hand side is still 3x minus 1. If you have identical statements on the left and the right, that means it doesn't matter what I plug in for x, it's always going to yield a true statement on the left and the right. For instance, if I plugged in 0 here and 0 here, it's still 3 times 0 minus 1, and that equals 3 times 0 minus 1. I can plug any number in here and there, and it's going to give us a true statement at the end. So I guess what I'm saying is, it's not no solution, it's every single number you can think of. Those are the solutions. So how we write that, and it's interesting because you'll see what we say is that if the variables drop out and it yields a true statement, all real numbers are solutions. And the reason why I say real numbers is because there are some things that you'd see later on in math, particularly math 2 or math 3, for sure pre-calculus if you get that far, is imaginary numbers exist. So we kind of have to discern between real numbers and imaginary ones. All the real numbers in the number system make this a true statement. So there's our second special case. All real numbers can be solutions if the x's completely drop out. You're left with 0x. And you're left with, hey, -1 does equal -1. That's a true statement. All right, let's practice a little bit. Let's back it up. That's a little too close probably for your comfort. All right, why don't you guys pause this video and try to do number 3 and number 4 on your own. Okay, let's see if you did them correctly. On number 3, looks like I got to get this +5 and multiply it through to both parts. So 5 times 2x is 10x. 5 times 3 is +15. The 5x just drops down here. Equals 2 times 7x is 14x. 2 times 1 is +2. Then you're going to do minus x. I'm going to put a 1 in front of there just to remind myself that there's a -1. Minus 1x plus 13. All right, second step. I want to simplify the left-hand side. So I don't have to move anything around. 5x plus 10x side by side, they're 15x. All right, over here I'm going to use the commutative property to say 14x minus 1x should be side by side. And then 2 plus 13 should be side by side as well. That's the commutative property. Again, I'm not asking you guys to document the actual properties off to the side, just knowing what you're actually, I guess, showing me the steps along the way, like this. All right, so I got 15x plus 15 is equal to, this is going to be 13x plus 15. Okay, so I want to make it clear by getting the x's on the left-hand side. So I'm going to undo the positive 13x with a minus 13x. So it zeroes it out on the right-hand side. The right-hand side is now 0 plus 15, which is 15. On the left-hand side, we have 15 minus 2, or 13, which is 2x. That plus 15 is still there. And now employ the subtraction property of equality to get this 2x term by itself. Subtract the 15 from here to zero it out. And then I subtract the 15 over here, which creates 2x plus 0. 2x is equal to 0. Okay, so this is interesting. We just got the special case of if the x's drop out and you're left with a true statement, it's all reals. If the x's drop out and you're left with a false statement, it's no solution. Students will oftentimes see this and think that it's a special case. But guess what? It's not, because the x's didn't drop out. The constants on the other side dropped out, but we can still solve for x. Divide by the number in front of x, and you've got an x by itself. Which makes sense. 2 times what gives me 0? 0. So, the 2 divided by 2 creates the x on the left. 0 divided by 2 is 0 on the right. Now, I would make a note of this off to the side, all right? I'll make it off to the side over here. X equals 0 is, so if you get this solution, is different than no solution and all real numbers. It's one solution. It's the solution when x equals 0. Not a special case. All right. Let's check out the last one, and then you guys can get moving on the assignment. All right, so no solution, all real numbers. Make sure we understand the difference between an x equals 0 and the special cases. What do we have on number 4? Well, just make sure, again, you followed the order of operations on this. Here, come on over. You would not do 8 minus 3 because subtraction would not come before the multiplication that has to happen here. So you're taking negative 3 times 2x, that'd be negative 6x. Then you take the negative 3 times positive 7, that's going to be minus 21. The 8 comes down. On the other side, it's just 6x plus 7. All right, simplify on the left-hand side. I'm going to take this positive 8 and put it side by side with negative 21. And then just minus 6x equals 6x plus 7. Again, commutative property. 8 minus 21 is going to be 13, and the biggest number is negative, so I'm making it a negative 13. Minus 6x is equal to 6x plus 7. Now, the reason why I put this particular problem on this homework document or on these notes is because a lot of times students think that they've come up with like a shortcut. They're like, oh, I see a 6x on the left and a 6x on the right. It's got to be a special case. And usually they'll come up with no solution because they're like, hey, that negative 13 and that 7 are not the same number. Here's the truth of the matter, though. That's a negative 6x and that's a positive 6x. They're not the same x's. In fact, if I subtract 6x from both sides, I get negative 6 minus 6, which is negative 12x. And that equals 0 plus 7. All right, so that's not a special case at all. That's just a random equation that needs to be solved for x. We add 13 to both sides because it's negative. So then you have 0 minus 12x equals 7 plus 13, which is 20. And then we divide by negative 12. If we mosey on over here, we can take the 20 over negative 12. And you can reduce that fraction by just cutting the top in half and the bottom in half. So divide the top by 2, you get 10. Divide the bottom by 2, you get negative 6. Still even, so you can keep cutting them in half. Cut the top in half and you get 5. Cut the bottom in half and you get negative 3. It's simplified, so turn it into a mixed number now. A positive divided by a negative yields a negative value. 3 goes into 5 one time with 2 leftovers. All right. So you've got some special cases. I showed you some other examples that can oftentimes get confused with special cases. Hopefully this was helpful for you guys. Thanks for watching.